So let's see the next subtopic of P3 algebra, which is the partial fractions. Now, partial fractions, in this, what we do is that whenever we have a rational expression with different cases, we are going to decompose them into different separate fractions. So three types of questions we will see in the exam. One where the denominator has all the linear factors. One where we have some of them or maybe all of them are repeated linear factors. And the third one is when we have one of them quadratic, at least one of them quadratic factor. And the question may come, what if we can factorize them? So if we can factorize them, then that becomes this type of case where you can separate them into linear factors. But if it's not factorizable, then we keep it in this form. So the case one, linear factors, repeated factors, we just decompose them according to the laws of taking the LCM. We have to consider both scenarios. So for example, let's say you have 3 by 8, for example. So you have to consider, sorry, let's go with 4. Let's go with 4. So we need to be able to consider one with a 2, one with a 4, because like 2 squared is 4. So two scenarios or two possible answers for this is that either it's 0 over 2 and 3 over 4, which is very easy to deduce, or if we keep both of them 1 and 1, we would get 3 by 4. So half plus quarter is 3 by 4. So but when we actually solve them, when we times by 2 to make the denominators constant, or same, sorry, this becomes 2 plus 1, 3 by 4. So just to be on the safe side or include all possibilities, we will have to consider the 1 with the power 1 also, and 1 with the square. So this is not limited to just the square. This could be cube also, so we would have to include the cubed term also. Okay, now these cases are easy to spot and we can easily memorize how to decompose them. However, the biggest important thing over here is that this form, whatever the question is giving us, we can only decompose them this way if we are given proper rational expression. Now, proper rational expression when the order of the polynomial of the numerator is less than the order of polynomial of denominator. So as you can see this over here also, maybe it's not exactly obvious, but if you see this is a squared, it's order 2, 3 linear factors, so that's a cubic expression. So 2 less than 3, that means a proper. Order 2, order 3, order 2, order 3 in the denominators. So they're proper fractions, proper rational expressions. If we are getting improper, we will have to convert it into the mixed expression first before we can decompose the proper part. So let's take an example to see what needs to be done for that. So for example, let's say we are given x 3x over 2x plus 1 x plus 2. Now the order polynomial is 1, 2x times by x becomes x squared, so that is order 2. So this is a this is a proper rational form, so this is okay for us. So we can decompose it, constant on the top, one of the factors in the denominators, second constant, second linear factor. So we can do it this way. Now, since we have two unknowns A and B, there we need two separate conditions to find them. So two unknowns, two conditions. So just like simultaneous equations, if we have two unknowns, we need two equations. Three unknowns, three equations. So solving them can be done in many different ways. Two of them are very easy to think about. So I'll name them. I'll show you the working for both of the processes, both of the methods differently, and it's up to you to decide which one you favor most. So I'll call this one method 1. So actually, hold on, sorry. Let me do one thing first. Let's make them, let's take the denominators the same. Let's take the LCM on the right hand side. This would become 3x, actually, wait, sorry. 3x over 2x plus 1, x plus 2, and a times by x plus 2 plus b o times by 2x plus 1 divided by 2x plus 1 x plus 2. Now, as you can see, you can cancel out the denominators because they are the same on both sides. And now you just have 3x is equal to this. Now, this form is slightly easier to work with. Now we can go on with the different methods over here. So I'll call this one method 1. In the method 1, since we have two unknowns, and the way to solve simultaneously is either by finding a way to eliminate one of the variables first. So we can do that. How we can do that is by eliminating one of the factors one by one. So simple rules of simultaneous equation. So what we need to do first is we take x plus 2 equal to 0, and that will give us x is equal to minus 2. So we will plug in x is equal to minus 2 in this entire expression. So this would become 3 minus 2 identical to a minus 2 plus 2 plus b minus 2 times by minus 2 plus 1. This entire thing goes to 0. We are left with negative 6 identical to minus 4 plus 1 minus 3b. So b would come out to be 2. Easy, straightforward. Let's use the other one. 2x plus 1 equal to 0. We will get x is equal to negative half. We plug it. 3 negative 1 over 2. A negative 1 over 2 plus 2. And since we are already putting 2x plus 1 equal to 0, so we don't need to even show that. So that's b times by 0, which already makes this entire thing to be 0. So minus 3 by 2. 2 minus a half is positive 3 by 2. So 3 by 2 cancelled. We are left with a is equal to minus 1. So it's a pretty straightforward process. Now let's see what we can do with method 2. So it's very similar to what we're doing, but instead of choosing the values to eliminate one of the factors one by one, we could choose any values and we would get the same answers. So let's see. Let's say, for example, I am arbitrarily choosing x to be 0. So let's see. Easiest numbers that we can think of. So 3 times by 0, a times by 0 plus 2, plus b 0 plus 1. So 0, 2a plus b. Very straightforward. And next one could be, for example, 1. 3 times by 1, a 1 plus 2 plus b 2 times by 1 plus 1. So 3a plus 3b, which could be further simplified as 1a plus b. So this is equation number 1, this is equation number 2. Now, since we have equations in both of these, we can solve them simultaneously. So 0, 2a plus b, a plus b equals to 1. Subtract them, minus, 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 cancels out. So a is equal to minus 1. And b we can find out with this equation simply. B would be equal to 1 minus a. So 1 minus minus 1, which would be 2. Exactly the same, exactly the same as what we found on the other side. Now, since we have found the value of a to be minus 1, b to be 2, we just need to rewrite this as that. So minus 1 and b is 2. That's it. That's your final form. So it's up to you which method you choose, whichever one feels more natural to you. There's absolutely no problem to go either way. All we have are two unknowns, so we just need two conditions, two values of x, so that we can have two separate conditions to solve simultaneously. So that's all. Now let's put a twist on the example number 1, and so example 2. Now, the difference between this question and the one above is that this was a proper fraction or proper rational expression. So we could just jump into the decomposition part. In this thing, order is 2, order is 2. So this is an improper fraction, improper expression. So we have to do the long division first to turn it into a mixed fraction, and then we can do the decomposition on the proper part. So we go through this process. This could be just a refresher for the long division process also. So 4x squared plus 7x plus 4. This multiplies to 2x times by 2x, 2x squared. X plus 4x, 5x, and then plus 2. Right, okay, now we do the long division. 4x squared plus 7x plus 4. 2x squared plus 5x plus 2. So to make it into 4x squared, we just need to multiply with 2. We get 4x squared plus 10x plus 4. Subtract, minus, minus, minus. 7 minus 10 minus 3x. And 4 minus 4 also gets cancelled. So that's it. So what we have over here, this can be rewritten as 2 plus, minus 3x over x plus 2, 2x plus 1. Now, if you notice, this is exactly the question we did just now. So we will use the same decomposition we did to plug this over here. The process is exactly the same. So we did the process except for the 2 part. So this entire thing would decompose into 2 plus, sorry, 2 minus, since we had this. So that's it. And this could further simplify to 2 minus 2x plus 2 plus 1 over 2x plus 1. That's it. That's your decomposition, partial fractions. Now let's see the other cases also. Okay. So, oh, by the way, this question, this one that was a May June 16 question. So May June 16 3-2 paper. I've forgotten the exact question number, but that was in there. So the next one, uh, this example is from May June 15. I'm using old exam questions for just as an example. We will have another video separately for the questions from 2023. Okay, so the question is that we have 11x plus 7 divided by 2x minus 1 and x plus 2 whole squared. So since this is the case 2, the repeated linear factor is 1. So we will have a over 2x minus 1. Second one would be x plus 2. And the third one would be x plus 2 whole squared. Now, the way to solve this would be a combination of method 1 and method 2. So the denominator on both sides, if we make them the same, would become 2x minus 1x plus 2 whole squared. But when we multiply on the right hand side, this would become a times by x plus 2 whole squared plus b 2x minus 1 x plus 2, and c would be only multiplied by 2x minus 1. Now, two of the values of x are very easy to spot. One could be minus 2, the other could be half. So let's see how we actually made that deduction. So x plus 2 equal to 0, that would give us x is equal to minus 2. So we plug this in. 11 times by minus 2 plus 7. Since we are making x plus 2 equal to 0, so wherever x plus 2 is, that would become 0. So a times by 0 plus b times by 2. Actually, the entire thing would be 0. And then this one, minus 2. 2 times by negative 2 minus 1. That would that. So this goes to 0. This goes to 0. This, however, becomes minus 22 plus 7. Minus 4 minus 1. So minus 5. Negative 22 plus 7 is negative 15, negative 5c, so c actually would become 3. Okay, now we proceed with the other number or other value of x that we can use, and that would be coming from 2x minus 1. So when we put 2x minus 1 equal to 0, we get a positive half. We plug in 11 times by 1 over 2 plus 7. A times by 1 over 2 plus 2 whole square plus, since wherever 2x minus 1 would be, that would become 0, so 0 plus 0. So 11 over 2 plus 7. 2 plus 1 over 2, 2.5 or 2.5, that's 5 over 2. So 5 over 2 whole square times by a. So this would become, the left side would become, sorry, 11 plus 7 times by 2, 14. 25 over 4a. Now we just cross multiply to find the value of a. 11 plus 14 is 25. So 25 over 2 times by 4 over 25, that would just be 2. So a is just 2. Now, there's a problem for the third one because we can't put 2x minus 1 equal to 0 because we have exhausted those which we could eliminate. So now for the third one, since we now know c and the a, we can plug in any number. So c, simplest number that comes to mind is x equal to 0. So 11 times by 0 plus 7. Oh, sorry. A we now know to be 2. A was x plus 2 whole squared plus b we don't know, right? B we don't know, so b we are trying to find out. So b times by 0 minus 1 and 0 plus 2. C we already know, 3 times by, that was 2x minus 1, so 0 minus 1. All right, so let's simplify. 0 plus 7 is just simply 7. 2 squared is 4. 4 times by 2, 8. Minus b and times by 2, so minus 2b plus 3. Oh, sorry, minus 3. So 7 minus 8 plus 3 equals to minus 2b. And 10 minus 8, 2. Oh, sorry, 10 minus 8 is 2. So 2 minus 2b. So b would be minus 1. So that's what we have. So now, technically, you would rewrite this entire thing. Okay, let's copy and paste this. So the final answer, therefore, would look like so b is minus 1. So minus 1. A was 2 and C was 3. So that's our decomposition. All right, so this was the repeated factors case. Now let's try a question for the quadratic factor case also. So this question is also from the May, June 15, but from the other variant. So May, June 15, 3, 2. Again, I'm using old questions just as an example. We will have another video for the recent questions. So 5x squared plus x plus 6 divided by 3 minus 2x x squared plus 4. Now, since this is a quadratic factor and we cannot further factorize this quadratic factor, so this would become a over 3 minus 2x plus bx plus c divided by x squared plus 4. Now, when we take denominators constant or same on both sides, this would become a times by x squared plus 4 and plus bx plus c times by 3 minus 2x. So first things first, let's go with the easy thing. Let's go with 3 minus 2x equal to 0. So x would be 3 over 2. So when we plug this in, this seems like a very long case over here. So you could do that also, or you could plug in any uh, other value also. But let's, since we have already written it, let's go for that. So 5 times by square of x, that would be 9 over 4 plus 3 by 2 plus 6. 8 times by 9 over 4 plus 4. Since the other side has 3 minus 2x, so that would become, the entire thing would go to 0. So 45 over 4 plus, let's multiply the 2 by 2 over here. So 6 over 4 and 4 times by 4. So 24 over 4, which makes the denominator the same. And on the other side, let's go do the same thing. So 4, 9 plus 16. So since the denominator is the same, so 45 plus 6 plus 24, that is 75. And 16 plus 9 is 25 over 4. 4 and 4 cancel, so a would be 75 divided by 25, which would be just 3. Now this was the easy part. Now for the x squared plus 4, there's no value that, that could easily make it 0. So we can choose any two values for our purposes. So x is equal to 0. So x is equal to 0. That would be 0 plus 0 plus 6. 0 plus 4 plus b times by 0 plus c, and 3 minus 0. And also, now that we know a to be 3, we can use 3 over here. Because the purpose of this is to reduce the number of unknowns. So if we know the a, we should use it. So 6, 3 times by 4, 12. C times by 3, 3c. This simplifies to 3c equals to 6 minus 12, which would be negative 6. So c would come out to be negative 6 divided by 3, negative 2. Now we know 2 out of 3 unknown. So for the other unknown, we can use any other number also. So x is equal to 1. So 5 times by 1 plus 1 plus 6. 3 times by 1 plus 4. Oh, sorry. B plus C. So B minus 2. And that is 3 minus 2. So 5 plus 1 is already 6. 6 plus 6 is 12. 3 times by 5, 15. Plus B minus 2 and my 1. So basically just B minus 2. So B would be equal to 12 minus 15 plus 2. So that would be negative 1. 14 minus 15, just negative 1. Now that we have found out A, B, and C, we just need to rewrite this back as the final answer. So therefore, the final answer so A was 3, B was negative 1, and C was negative 2. So minus x minus 2, or you could take out the minus also. You could also rewrite it as 3 over 3 minus 2x minus x plus 2 over x squared plus 4. Equally fine, basically. So that's that's all the cases that we need to know for the partial fraction. So the use of partial fractions could come in the form of integration questions also, or just uh, decomposition questions also. So hopefully in the next video, we will see the recent questions from 2023. All right, so take care. Bye-bye.